Hi guys, we are all missing you and wish we could be together. Because rocks are such a fun topic, and I'm sorry you can't pick up the rocks to see the differences. You have already seen igneous and sedimentary rocks, and now we're going to tell the story of how metamorphic rocks begin their journey. This is an igneous rock. Its main distinguishing characteristics is intergrown crystals in a random pattern. This is a metamorphic rock. Quite different. Its mineral crystals are organized, not random. We are going to look at what causes metamorphic rocks to be organized. In this picture you can see a metamorphic rock that has a pattern of alternating light and dark minerals. The light minerals are felsic and the dark minerals are mafic. Before we begin, be sure to have your ESRT open to page 6 and 7. As we have started off with each rock, we look at the rock cycle chart on page 6. We have learned the processes to become an igneous rock are melting and solidification. To become a sedimentary rock, it is deposited in horizontal layers, buried, compacted, and cemented. The processes to become a metamorphic rock are increasing heat and pressure, causing metamorphism to happen. Notice that every rock type can turn into another rock type. If you break down the rock name, meta means change and morph means form. What that means is any pre-existing sedimentary, igneous, or another metamorphic rock can change their form if heat and pressure are added. It does this while the rock is still a solid, but the mineral composition and the texture will change. We call the pre-existing rock the parent rock. Some of the ways rocks undergo heat and pressure are at convergent plate boundaries, where two plates are coming together. But another way is when magma intrudes into rocks. Based on how they form, we have two types of metamorphism. Regional metamorphism happens when the two plates come together at convergent plate boundaries, resulting in mountain building. Contact metamorphism is when magma intrudes into the existing surrounding rock or lava extrudes on the surface. On page 7, the type of metamorphism is listed in the middle column under types of metamorphism. The rock that forms from regional metamorphism have some differences from the rocks that form from contact metamorphism. Let's see how heat and pressure affect the rocks. You may not know this, but heat increases as you go from the Earth's surface to the core. So does the pressure. Also, obviously, if a rock is in contact with magma, the heat will increase. What this does is the heat causes the minerals to recrystallize into a new higher temperature mineral that is stable at the new temperature. Pressure also increases with depth, but there is also pressure when two plates come together or collide with each other. Pressure makes these new mineral crystals grow larger, become denser, and they start to move into parallel layers that are perpendicular to the pressure. This mineral layering is called foliation. If the rock undergoes more heat and pressure, the felsic minerals separate from the mafic minerals into alternating mineral layers called banding. That was like the picture on the first slide. Banding is extreme foliation brought about when the rock is brought deeper into Earth's interior. We're going to watch this video that shows you the two plates colliding and the pressure and what it does to the random intergrown crystals. As they undergo metamorphism, they become parallel to each other, and you will get a rock that looks like this, the foliated gneiss. This is an animation of what happens to granite when it undergoes heat and pressure. The random intergrown crystals that are granite will undergo metamorphism, and they form the metamorphic rock called gneiss. And you can see the foliation, the alternating light and dark minerals. This is banding. This is just a visual representation of the igneous rock granite that has the random arrangement of minerals undergoing metamorphism that organizes the arrangement of minerals due to heat and pressure. If the rock shows banding, it has undergone extreme heat and pressure at great depths into Earth's interior. Other rocks can undergo metamorphism. This diagram shows what happens to shale as more heat and pressure is added to the rock as depth within the Earth's interior increases. Clay gets compacted and cemented to form the sedimentary rock shale, which stays a sedimentary rock until around a depth of about 7 kilometers. Then the heat and pressure increases and the shale metamorphoses into slate. This is called low-grade metamorphism. If the slate gets to a depth of about 14 kilometers and a temperature of about 500 degrees Celsius, the slate metamorphoses into another metamorphic rock called phyllite. If the phyllite goes deeper, it metamorphoses into another metamorphic rock called schist. If schist is brought to a depth of about 27 kilometers and a temperature about 600 degrees Celsius, it metamorphoses into gneiss, the only rock that shows banding. This is called high-grade metamorphism. If gneiss is brought any deeper and hotter, that sucker melts, and no matter what rock it was before, as soon as it melts, when it cools and solidifies, it is now an igneous rock. So, any type of rock, as soon as it melts, when it cools, it will become an igneous rock. Metamorphic rocks are often deformed because of this intense heat and pressure. If you look at the rock symbol for gneiss on page 7, you can see that the symbol shows some distortion. Here is an example of a deformed gneiss. Most of the regional metamorphosed rocks are foliated because of the pressure. The second type of metamorphism is called contact. Contact metamorphosed rocks do not show foliation because while there is heat associated with the magma intruding the surrounding rocks, there really isn't pressure. The magma just bakes, aka recrystallizes the minerals so that the rocks touching or adjacent to the magma are baked. This next slide shows the magma intruding in the surrounding rock. So there's the magma intruding. Any rock that gets melted and becomes magma, when it cools, is igneous. So all of this rock in here will become igneous. The orange rock that is adjacent to the magma gets baked and the minerals get recrystallized, forming new minerals, and that forms a metamorphic rock. The surrounding sedimentary rock is untouched by the magma. So this is unaffected, the blue. This orange becomes the metamorphic rock, and this is the igneous rock. So I've got magma, this is the contact metamorphosed rock, and this is unaffected. So this will show you, you might get sandstone, shale, and limestone. This slide summarizes what happens. Magma in contact with the surrounding rock bakes or recrystallizes the rocks in a narrow transition zone, kind of marked by the yellow tick marks or arrows. Where the yellow tick marks are is where the metamorphic rock forms. These rocks are not foliated. The metamorphic rock chart is separated by foliated and non-foliated. The contact metamorphic rocks are on the bottom of the chart, and if you look in the comments column, the parent rock is identified. So if you look here in this comments, the metamorphism of limestone or dolostone becomes marble. So this is an example. The parent rock is limestone, and it metamorphoses into marble. So that's kind of a brief overview of metamorphic rocks. We will be following that up with some other assignments.